Did you have the experience that you were playing a computer game and you found that the computer was so clever that you could hardly win the game? Maybe you will ask, how can a computer play games with human beings? So today we'll present you how the computers use game trees and minimax algorithm to play games with you. In this video, we will use tic-tac-toe for example. At first, we'll make sure the rules of tic-tac-toe. Players alternatively put X and O's on the game board, and if a player is able to draw 3 X's or O's in a row, either horizontally, vertically, or diagonally, that player wins. Now let's have a look at how humans deal with this game. If I am O's player and it's my turn, I will put my O in this block because otherwise I will lose. From this we know that if we want the computer to play this game as a human being, it should act rationally, which means it will try to win the game. Also, it should assume the opponent to be a rational player, and it can prevent the opponent from winning. Now let's see the computer's approach step by step. Assume we have the board position shown in here and it's X's turn now. What will X do next? There are only 3 blocks available, so there are only 3 options for X can take. If a human is playing, he will not take these 2 moves since he will lose directly in the next move of O. However, how can a computer choose which move to take? Well, it's possible for a computer to build such a tree to simulate the 3 possible moves. So, how about we keep simulating until the end of this game? Yes, this is what we want to introduce you today. A game tree. A program can build a game tree from the current board position. Since the tree can contain any possible moves to take, the program can just choose currently which move.
Now I will take care of the rest part. From above, we have constructed a large tree, but what is this tree for? Of course, it helps us to make a move, and now I will introduce a search method to help you make a move. First of all, we have to define some states in our game. The only 3 scores we will have are positive 1 for a win by cross, negative 1 for a win by O, and 0 for draw. As you can see in this tree, then we can learn how to make a decision. In this game tree, each level represents a move. You should choose a step to take, and the tree steps will increase by 1. For the X turns, you should take the maximum value of this level, while the O's turns is the opposite, the minimum value. You must be confused. How can I calculate the value of each node? Don't worry, I will take care of this. We will calculate the value from bottom to top such that each list only has 3 possible values, negative 1, 0, positive 1. For the other node, the value will be given by its children. Now we take an example for this tree. All the blue values are the least value, and it's easy to calculate because the winner is already determined. In this level, each node only has 1 child such that its value is the same as its child. Between these 2 levels, it's O's turn to move, and O will take the minimum value such that all these levels node value will take its children's minimum value, as you can see are negative 1, negative 1, 0. Is it clear? I will give you some time to think about it. Alright, we will continue to our next page. Here, we will introduce how to achieve this algorithm. Have you ever heard recursion? We will use this method to implement the algorithm we have proposed just now, called minimax algorithm. For the first 2 lines, it means that if we reach 3 leaves, we will return the winner, which is the value of the leaves. And if the max turn, we will return the maximum value of its children, while for the min's turn, we will return the minimum value of its children. Both these 2 steps are processed by calling the same function minimax. And this is the recursion. As a result, we will calculate the value of each node from the bottom to top. Now we will have all the values of the tree such that we can make a decision by these values. Alright, now we will make a conclusion now. From what we have talked about so far, you know how a computer to make a move in tic-tac-toe game. For the most other classic board game, we can use this method to implement a computer program to play a game, like chess, checkers. However, this algorithm running time is expensive. If we use this algorithm for chess absolutely, we can have the correct move, but it is not possible to take this. Otherwise, we will use another algorithm called alpha-beta pruning to deal with it. But with limited time, we won't discuss it this time, maybe the next time. Thank you for seeing this video.